I'll say, let's go ahead, and as people join in, we'll be able to welcome them as they join the webinar. So thank you so much, everyone, for being here today. We really appreciate having you with us. Today's webinar is going to talk about the defense, autonomous vehicle and the defense industry. We're really happy to have you here again, and we'll start with the presentation that we have. So just a little bit about me so you know who you're talking to. I have a background in autonomous vehicle technology. For the last 10 years, I've been working in that industry, working in different projects in different type of industry. It's a passion for me, so I'll try to keep it short when I go on all the possibilities of autonomy in all the different industry. But just wanted to give you a little overview of who I am. I'm working with OPAL-RT right now, helping on the business development on the 4Drive team. And I am lucky to have my right-hand person, and as I usually say, the smart part of my brain, being Valentin, is with me today to do that webinar. So Valentin, if you want to introduce yourself.
Yes, thank you, Marie-France. Hello, everybody. So my name is Valentin Pifroca. So about myself, I have a background in electrical engineering, and for the last four and a half years now, I've been working with OPAL-RT under the autonomous division OPAL-RT 4Drive. And it'll be my pleasure to introduce you to the product more technically and see how it can help you in your defense, let's say, endeavors.
Great. So we'll jump in just to give you an overview of what OPAL is. So OPAL was created in 1997. We're working a lot in power electronic, in the automotive, aerospace, power electronic, power generation, world leader in real-time simulation and HIL testing. The value that we have is fast innovation, cooperation, caring, performance, and openness. We have a team of more than 400 people worldwide that is working with OPAL. So if you are attending today and you are in another part of the world, interested to know more about what we do in your region, please reach out. We'll be happy to put you in contact with the person in your region. So we're going to jump into OPAL-RT 4Drive. So OPAL-RT 4Drive is the creation that came from the acquisition of 4DV simulation, 4DV virtualized. That happened 2 years ago, and now with the OPAL-RT 4Drive, we're bringing together the software part with OPAL, the 4DV simulation, but also with the Xeon, with the HIL component for the autonomous vehicle testing. So why is virtual testing so important? First of all, because it speeds up your development or your testing phase. It's cost saving because it reduces all your field testing, integration, onboarding costs, but also if something happened to your vehicle while you are testing them, risk reduction. So test all the different edge cases that you can find, the critical failure in a safe environment before you actually go into doing real life testing. Flexibility, because you can reconfigure your vehicle dynamic and sensor in minutes, not months. So it's something very quick and easy, a drag and drop type of approach where you can do all those testing. And then it's scalable because you can move from small scale academic research to industrial grade deployment. So 4DV simulation is a one unified ecosystem split into different tools that you can combine or select just specific elements. Just wanted to say, if you have any question while we are presenting, please put the question in the Q&A. If we are able to answer them as we go, that would be great. If not, we'll keep them for the end and we'll make sure to answer all of your questions. So please do not hesitate. Don't be shy. It's the best thing that happens is when we have conversation with you guys to make sure that the presentation we do is relevant to what you're looking to accomplish. So the 4DV software suite, like I said, is a combination of different tools. Very sorry about that. Generation of different tools, specialized in development and in contextual sensor data. So it defines your test environment, development of mobile, robot, drone, autonomous vehicle, and AI. This is something very unique to 4DV simulation, is the combination of all those different type of product, and the robotic angle of it is very important for us. What you do with the 4DV-SIM is you simulate the sensor to generate the contextualized data that you'll need to for your testing. Then you facilitate the test and the reliability for the embedded system, lower cost for prototype, test and validation under close condition of your use case. Especially if you think of defense, it's never really a testing environment where it's easy to find. It's usually remote or really secluded area. So having the possibility to do it with virtual testing will really facilitate that for you. Exploitation of the plug-and-play connection with your embedded hardware. So those are all elements that the 4DV suite offers to you. So the real-time and hardware-in-the-loop 3D simulation testbed, what we do is define the context. Sorry, I'll just wait for the slide to be there so you can follow what I'm saying. So define your context, use the library 3D environment, pedestrian vehicle, all the weather disturbance, the 3D objects that you would like to put into the simulation with your 3D environment, and then all the robots or the drone or the vehicle that you have. Then you have the instrument with the same sensor. So generate or emulate from real sensor. The same mode of communication, so the communication protocol as with the real system. So the visual and physical sensor are added into the simulation. Then you have the interface with the tool. So you can do co-simulation or just simulation with the 4DV and analyze all the tools that you have. Then you have connect the embedded system of your functional digital twin, so hardware in the loop simulation, that's a Xeon approach, and then plug and play everything to simulate and generate the data in real-time simulation. So generate the functional simulation to quickly provide data in use case which are difficult to access, dangerous. It's really something important when it comes down to the defense environment. You'll never have, or you rarely have, an environment where it's smooth road or perfect condition to have your autonomous vehicle running. So that's why having the opportunity to create environments that are more similar to the situation that you'll have your mission, or that you have your mission command and your deployment that will be done is good to do with the simulation. And then test and debug your algorithm, all the perception, localization, control, communication protocol, what happens if there's some communication that falls through because of the environment of the defense project. Connect instantly your embedded computer from your digital twin to your real system. Improve the reliability of your algorithm or with the automized test that we can do, and then generate automatically database and annotate image for learning stage that you can use by your AI, and then develop the test and improve your user interface and the functional using of your control. It's also a good way with the simulation to make sure that the troops or that the mission that you have is well aware of how the vehicle is working, how it's interacting, and what to do in those situations. So those are the different suite that we have into the 4DV-SIM software. I'll let Valentin go a little bit deeper in all of them, just to give you more information on all of those elements. Valentin?
Yes, perfect. Thank you, Marie-France. So as Marie-France explained, right, there's a whole process into creating a simulation. So now let's look at the different software components that compose this software suite, the suite of tools that is 4DV-SIM. So let's start with the 4DV simulator there in the center, right? It is the piece of software that takes a simulation, let's call it a scenario, that takes it. The scenario contains all the sensor models, your systems, and the interfaces between the sensor data and your controllers in the loop. So that's what the simulator does. It runs the scenario and generates the data, communicates. Right? But how do we create a scenario? Well, we use the one of the tools, the 4DV editor there that you see, create scenarios. So what is a scenario? It's a collection, yes, of different visual elements. So 3D models of environments of your own systems or of systems of our library, instrumented with the sensors placed around the vehicles as you'd like. One sensor, 10 sensors, it will depend. It will affect the performance as well, but it's up to you to define those things using the editor. Now, how do we integrate a new system into our software is through the 4DV system designer just above in order to build models, to build systems. So what we allow is the import of drawings, essentially a 3D model, which is for all intents and purposes a drawing, to which we add physics. So we through system designer, we configure things like what the mass, inertia, coefficient of friction, and joint parameters, essentially, of your systems from a simple four-wheel vehicles to tracked vehicle like tanks or things that rely on tracks to various kinds of robots. Really, 4DVSIM is at its core a robotic simulation platform. So all of these tools are used to generate the scenario that you want to simulate. On the side of that, we have two tools, the 4DV monitor and 4DV batch. I'll start with the 4DV monitor on the top right of the screen. So that's basically our visualization tool for the sensor data that the 4DV simulator is generating. If you don't already have your own visualizers, it's something that we offer. The second tool down there, 4DV Batch, that's our tool to help you automate your testing by allowing you to introduce some randomization into your scenarios while also letting you run analysis scripts essentially in between your runs of the simulation so that you don't have to do that manually. It's all automated thanks to 4DV Batch. So that sort of summarizes the software suite. I believe we have a couple more slides just to give you an idea of what the GUI looks like, the graphical user interface. So here's the editor quickly. So it's graphic user interface where we pick and choose from our library, either 4DV's library or your own custom library. We have on the left side a 3D view of the elements to place them uh, rather simply and rather quickly. And on the right hand side, you have what we call the graph view, which is where we perform the different connections between, let's say, sensors and communication interfaces, or communication interfaces to your systems for information like speed and control commands. So this is just a quick overview of this. Next slide, we have uh, the 4DV system designer. In fact, this slide was to show you how large of an environment we can introduce. So this is about a 5 by 10 kilometer environment. It all depends on the number of vertices, of course, into your models. But we can simulate large environments like this to perform long-lasting missions going through different terrains over mountains, etc. If we go to the next slide, we get a closer look at the definition. Right here, we see more of the physics side of it, the mesh definition of the environment, the ground, and some of the trees that are populated in that environment. So 4DV System Designer is used to bring in these models, these 3D models, and give them again their physical properties so that well, you get a realistic simulation. Yes. And I believe I've got one more slide actually on the 4DV monitor to give you an idea of the different cameras, the different visual elements that we can use that exist to visualize the sensor data. We see some LiDAR, point cloud, some cameras, obviously, some elements for orientation of likely a drone on the top right corner. So all of these elements are part of the software suite. Yes. Now for the next section is going to be an explanation on how 4DV can help you in your defense simulation with supporting evidence, with supporting videos, yes, on what has been accomplished. Yeah.
So we're going to share with you the video. And again, I'm making that disclaimer every time just because I want to make sure. But sometimes when we show it through a platform like Zoom, like Team, like any other platform, there could be a little bit of lagging into the video. But rest assured, this is not something that we see when you are doing that from your own computer, when you're doing it for yourself. So it's just a disclaimer. Don't be surprised if you see that. It could happen. It's not always happening, and it depends on your connection, your internet, and everything else. So just a full disclaimer on that. But enjoy the video.
Welcome to this presentation on 4DV-SIM. 4DV-SIM is a multi-domain simulation platform designed for autonomous ground and aerial robots operating in complex, realistic environments. It is neither a true training program nor a high-level wargaming tool, though it integrates with both. So here's what makes it different. First, the multi-domain and multi-agent simulation. So 4DV-SIM simulates ground vehicles again with wheeled or tracks, unmanned aerial vehicles, and swarms of them simultaneously. A single scenario can run up to 100 drones with full flight dynamics, all while managing ground convoy operations in the same environment in real time. Generic and commercial sensors. Every sensor in 4DV-SIM is configurable. You can use generic sensors or pre-configured commercial sensors that replicate the real-world behavior, including their exact communication protocols and data structures. For example, a LiDAR doesn't just return a perfect point clouds, it returns what a real LiDAR returns, coherent in time, with no drift. And a GNSS sensor doesn't give perfect coordinates. It includes noise, latency, obstructions with the buildings and trees, and, well, availability of the actual satellites in an accurate georeferenced environment. So this fidelity matters because your autonomous controllers are trained on real data and the need to see realistic data in simulation. The environment, so off-road simulation is our core. So rough terrain, friction coefficients, material properties, all of these things are configurable and importable in 4DV-SIM. So you can build a scenario from real-world 3D models, so import it as meshes, adjust surface properties, the static and dynamic frictions, how the light interact with the material, and other visual elements, and populate it with obstacles, different vehicles, and contextual objects. Your simulation environment can reflect a desert, a mountain pass, urban terrains, any environment really where your autonomous systems will operate. The C++ API and co-simulation. So for teams that need to extend the simulation platform, 4DV-SIM exposes a C++ API where you can write custom controllers, integrate third-party libraries, or really perform any simulation logic. This code executes at the simulator's time step or the frequency you specify, so your code runs deterministically alongside the physics of the simulation. This is how you build custom autonomy layers without leaving the simulation environment. And it's great for exploring control strategies before or even after getting your hands on the real hardware. Unreal Engine 5 co-simulation. 4DV-SIM co-simulates with Unreal Engine 5, the industry standard for high-fidelity visualization. Here's how it works. You build your scenario in 4DV System Designer, the vehicles, the sensors, the terrain, the physics all configured. Then, through a resource transfer between System Designer and Unreal Engine, the environment syncs. And so your vehicles, terrains, and object placements carry over seamlessly, minimizing rework. If you need to optimize certain things like the level of details, refine materials, or add custom visual effects proprietary, let's say, to Unreal Engine, you can do that directly in the Unreal Engine editor. But the heavy lifting is already done. That way, your simulation runs the physics in 4DV-SIM while rendering in Unreal's graphics engine. You get photorealistic visuals for your software stack, your stakeholder demos, operator training, etc., without sacrificing on the sensor realism, the multi-agent physics that make the simulation so valuable. Closed loop validation. So here's the critical part. 4DV-SIM doesn't just simulate vehicles and sensors in isolation, it closes the loop, the simulation loop. So sensor data flows out of the simulator to your real autonomous controllers, whether they're running in software in the loop or in hardware in the loop. Those controllers send back control signals, speed steering, flight commands, etc. The simulator ingests those commands and updates the vehicle state in the physics engine, keeping the data coherent, even in the case of slower than real-time simulation. That tight feedback loop is what lets you validate that your actual controller, the code, actually works in a complex dynamic environment in software in the loop, and even the actual hardware is working properly in the case of hardware in the loop simulation. Finally, integration with wargaming and other ecosystems. So while 4DV handles the physics and again the behavior of the individual vehicles, the multi-agent coordination, it can integrate with higher level what we call C2 systems that handle strategy and operational planning. So a high-level wargaming or C2 system might plan route a 10-vehicle convoy through this mountain pass under GPS denial with a mixed vendor platforms, let's say. Now, so 4DV-SIM gives you this answer, right? Can those vehicles actually execute that plan? Will they collide? Can the LiDAR on the lead vehicle detect obstacles ahead? Or what happens when the GPS degrades? Do the controllers maintain cohesion? You know, all 4DV-SIM lets you test whether a C2 decision actually works in a realistic scenario with those sensors and the control systems plugged in. That's it for the demonstration. Thank you.
Thank you so much, Valentin, for the video. Just want to say to everyone that our team is going to be attending the event in Stuttgart in 2 weeks. So there's going to be more into the defense industry that will be presented there. So stay tuned. We're going to be able to share more with you in the upcoming weeks and months. I'm looking at the Q&A section. I do not see any question there. Please don't be shy if you have anything that you want to ask to put it there. In the meantime, let's just start with one question that we hear a lot, Valentin, when we have meetings with defense industry. Where's the handoff between the wargaming simulation and the 4DV-SIM? How does it interface exactly?
Mm-hmm. Thank you, Marie-France. Well, first of all, there's the aspect of communication, right? More technically, the protocols that we use and how does that work. So we have a certain expertise in developing and integrating the various communication protocols. So it's something like DIS or HLA, which are standard in this industry. is something that we support. So beyond that, it's more about what these C2 systems again are simulating, and where certain assumptions can be actually answered, or certain questions. So again, in that same example I gave in the video, where a certain convoy had to be routed through an area, it may not be relevant to physically tested ground units. Soldiers can walk through an area, but a vehicle going through difficult terrain, there's a certain assumption there that, yeah, the vehicle just gets there, but can it really, is the question that we answer. And so there isn't, it's not so much as we add something as we really we solve this question mark. And so it's in that instance where the vehicles are there, whether it's even teleoperation or the actual intelligence of these vehicles connected. The point is we bring that to this broader C2, let's say, view of the battlefield, yeah, of operations.
So you validate assumption that you might have with the wargaming system.
Exactly. And it's not a defect by any means of those models, but more that we augment the simulation capabilities, right, in terms of software, but also as OPAL-RTs are roots in also in hardware validation. So can the actual controller connected to this simulation, can perform as expected on top of, yeah. So
yeah, great. So we have two questions. The first one, a PhD student want to ask if this software is available for the academic experimentation and training. The answer is yes, absolutely. We have multiple universities or academic institutions that are using 4DV. So Hartzell, if you want to have more information, please connect with us. We'll be able to provide you more information for sure on that. But the short and sweet answer is yes, absolutely. Then we have a question from anonymous attendees. Does the 4DV run on the cloud or as software on a local PC? Right now, what we are doing, because we have a couple of clients in the defense industry, is everything is working on your own PC. So it's not cloud-based at this time. It's a USB key that you can install into your own system. And because we know how sensitive the Defense Department or defense industry is, this is your system and we don't have access to what you are doing. So it's very private. It's not located in a cloud somewhere where anyone could have access to the testing you are doing. It's you and only you that gets access to that. We can help you in some elements of what you're looking to accomplish, but most of I would say all of our defense client that we have, it's kind of we give you the black box and then the system is running on your side, and we are not able, and we don't want to, and we know you don't want to, have access to everything that you are testing through that. We're just there to support and help you to accomplish what you're looking to do. I'm looking, I don't think we have any more questions, and we are at the end of the time that we had planned anyway. I would like to thank everyone for participating into the webinar that we had today. We're really happy to have you here. If you have any question, because sometimes it's a lot of information that we share with you in a short period of time. If you have any question, do not hesitate to reach out to us. We'll be more than happy to provide you more information on specific elements. And look at the website for OPAL-RT 4Drive. We have 2 more webinars coming in the fall. And OPAL also have other webinars that are happening. You can see the dates there. So mark your agenda, and we hope to see you soon on the next one. Thank you so much, everyone, for attending. Have a great day.
Have a great day, everyone.